Welcome to our exploration of the biomechanics of human skeletal articulations. Today, we're diving into the fascinating world of cartilage, focusing on two key types, articular cartilage and fibrocartilage. These specialized tissues play crucial roles in our joints, enabling smooth movement and providing essential support. Understanding their structure and function not only helps us appreciate how our bodies work, but also sheds light on why joint health is so important. Let's start by setting the stage for what makes these tissues unique and why they matter in everyday life and movement. Articular cartilage is a smooth, white tissue that covers the ends of bones where they meet in synovial joints. This tissue is made of hyaline cartilage and is typically 1 to 5 millimeters thick. Its unique structure allows it to be both soft and porous, yet durable enough to withstand the demands of daily movement. The main job of articular cartilage is to reduce friction, absorb shock, and allow for smooth, pain-free motion between bones. Without it, our joints would be stiff and prone to damage with every step or movement. Delving deeper, articular cartilage is composed of specialized cells called chondrocytes, which are embedded in a matrix of collagen fibers, proteoglycans, and other proteins. This matrix gives the cartilage its strength and flexibility. The tissue is highly hydrated, making it soft and permeable, which is essential for its shock-absorbing properties. However, one downside is its limited ability to heal when damaged, which is why joint injuries can be so problematic and slow to recover. Articular cartilage has two main functions. First, it spreads loads over a wide area, reducing contact stress on the bones. This means that when you walk, run, or jump, the force is distributed evenly, protecting your bones from damage. Second, it provides a protective lubrication that minimizes friction and mechanical wear at the joint. This lubrication is crucial for maintaining joint health and ensuring that movements remain smooth and pain-free throughout life. Fibrocartilage is a tougher, denser type of cartilage packed with collagen fibers. Unlike the smooth, glassy appearance of articular cartilage, fibrocartilage is more fibrous and robust. It's found in places that require extra support and shock absorption, such as the intervertebral discs in your spine, the menisci in your knees, and the pubic symphysis. Its structure allows it to resist compression and provide strong support where it's needed most. Fibrocartilage is composed of both type I and type II collagen fibers, making it thicker and stronger than articular cartilage. This combination of fibers gives it the ability to withstand heavy loads and absorb significant shock. Its dense, fibrous appearance is a direct result of its high collagen content, which is essential for its role in supporting and stabilizing joints that experience high stress and movement. Articular cartilage is found at the ends of bones in synovial joints, such as the knee, hip, and shoulder. In contrast, fibrocartilage is located in areas that require extra cushioning and support, like the intervertebral discs, menisci of the knee, and pubic symphysis. These strategic locations highlight the specialized roles each cartilage type plays in maintaining joint function and overall skeletal health. Articular cartilage has a smooth, glassy, bluish-white appearance, which helps it minimize friction and allow for seamless movement. On the other hand, fibrocartilage is dense, tough, and fibrous, designed to withstand greater mechanical stress. These differences in appearance and texture are directly related to their distinct functions within the body. Collagen content in these two types of cartilage is a key factor in their function. Articular cartilage primarily contains type II collagen, which forms fine fibers that provide flexibility. Fibrocartilage, however, contains both type I and type II collagen, with thicker fibers that offer greater strength and resistance to compression. This difference is crucial for their respective roles in the body. Articular cartilage is more flexible but less strong, making it ideal for joints that require smooth, gliding movements. In contrast, fibrocartilage is very strong and resists compression, which is essential for joints that bear heavy loads or experience repetitive stress. This balance between strength and flexibility ensures that our joints can move freely while remaining protected from injury. One of the challenges with cartilage is its limited ability to heal. Articular cartilage has very poor regenerative capacity, meaning injuries often persist or worsen over time. Fibrocartilage has a slightly better ability to repair itself, but it's still limited compared to other tissues in the body. This is why joint injuries can be so problematic and often require medical intervention. Articular cartilage plays a vital role in joint health by spreading loads over a wide area, which reduces contact stress on the bones. It also provides a protective lubrication that minimizes friction and mechanical wear at the joint. These functions are essential for maintaining pain-free movement and preventing long-term joint damage. Articular fibrocartilage refers to soft tissue discs or menisci that intervene between articulating bones. A common example is the menisci of the knee, which act as cushions and stabilizers within the joint. These structures are essential for distributing loads, improving the fit between bones, and protecting the joint periphery. Articular fibrocartilage serves several important functions. It distributes loads over joint surfaces, improves the fit of articulating surfaces, and limits the slip of one bone with respect to another. Additionally, it protects the joint periphery, retains joint lubrication, and absorbs shock at the joint. These combined roles help maintain joint stability and health, especially in high-stress areas like the knees and spine. Summary: both articular cartilage and fibrocartilage are essential for healthy joint function. Articular cartilage enables smooth, frictionless movement, while fibrocartilage provides strength and shock absorption in high-stress joints. Understanding their differences helps us appreciate the complexity of our bodies and the importance of protecting our joints through healthy habits and prompt care when injuries occur. By maintaining joint health, we can enjoy pain-free movement and an active lifestyle for years to come.